In this lesson, we're going to learn about scale factor, and we're going to use proportions to help find our answers. Remember, pause the video at any time you need. A scale drawing is a drawing where the dimensions are proportional to the actual size of the object being drawn in a predetermined ratio. The scale is a ratio of the size of the drawing to the size of the original object being drawn. So the drawing compared to the original is the scale. This may be referred to as a scale ratio. Units can be different and are included with scale ratio. So in this example, we have an actual house and then we have the drawing. The scale is 2 inches in the drawing compared to 5 feet of the actual house. In this example, our scale ratio is 1/2 inch on the map represents 3 miles in real life. Scale factor. Scale factor is a number used as a multiplier in scaling, making an object smaller or larger. So remember, guys, when you hear the word factor, you should think multiply. So the word factor indicates multiplication. The term scale factor is the ratio of a measurement of the new image compared to the corresponding measurement of the initial image. Units are not included with scale factor. Make sure you take note of that. So scale factor, you'll see, we'll use a K to represent scale factor. It's going to be new compared to the corresponding initial measurement. New over initial. So here are our formulas. So if our scale factor is more than 1, we've multiplied by a number more than 1, we have enlarged an object. If our scale factor is between 0 and 1, like 1/2, we have reduced an object. If we multiply by 1 and our scale factor is 1, we've just created a congruent object. So remember, it is new compared to the initial. Let's take a look at our first example. A building is 24 feet. The height of the drawn building is 8 inches. What is the scale factor? So a building is 24 feet. The height drawn is 8. So let's say 8 inches on the drawing to the original 24 feet of the building. Let's simplify this. And we're going to get 1 inch per 3 feet. So that's the scale ratio. Now we want to get the scale factor. We don't want any units. So we're going to use this conversion ratio to convert and get rid of our units. So 1 feet equals 12 inches. I'm going to put feet in the alternate spot of where it is in our scale ratio so that they will cancel. 1 foot is the same as 12 inches. So you can see the inches cancel and our feet. So I have no units. So now I'm going to multiply, and our scale factor is 1 to 36. That means the drawing is 1/36 the size of the actual building, or the actual building is 36 times bigger. Okay, the model car measures 12 centimeters long. The car is actually 4.5 meters long. What is the scale factor? Let's first do our scale ratio. So the model is 12 centimeters. The actual car, 4.5 meters. Let's simplify this. I'm just going to use my calculator and simplify. And we're going to get 1.25 centimeters over 1 meter. Now let's use this conversion ratio here to cancel units to find scale factor. So I'm going to put meters in the top because it's in the opposite location of the meters in our scale ratio. So 1 meter is the same as 100 centimeters. Cancel, 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 cancel. We're going to multiply straight across and divide, and our model car is 0.0125 times smaller than the actual car. That is the scale factor. So we created a scale ratio, we simplified, we used a conversion factor, a conversion ratio here to get rid of the units because scale factor does not use units. Now let's take a look at, we have a rectangle. Here's the initial rectangle in our new one. To find scale factor, we can compare corresponding parts. So we're going to start with a new, because remember it's new compared to the initial. So 4 corresponds to 12, or we could say 16 corresponds to 18. They both simplify to the same ratio, so our scale factor is 1/3. This new rectangle is 1/3 the size of the initial. Now let's compare perimeters. So I always like to do the measurement of the new one first, just so I make sure I put that on the top part of my ratio, finding scale factor. So perimeter is adding all 4 sides here, and so we get 20. And then we're going to add all 4 sides of our initial and get 60. So we're going to compare the 20 to the 60, and that does give us the 1/3. Area is length times width. So now we're talking about 2 dimensions, not just a single linear. So 4 times 6 is 24. And then we're going to multiply 12 times 18 to get 216. Let's compare 24 over 216. And when I simplify this, I get 1/9. And the reason we get 1/9 is because when we're talking about area, remember we're talking about 2 dimensions, we are squaring, so to speak. So if I take my scale factor of the dimensions, of the linear dimensions, and I square it, we get 1/9, which is the value we would use for area when we're talking about scale factor. Okay, let's take a look at one more with triangles. Again, we are going to compare new to initial. So we can say 9 compared to 6, or 12 compared to 8, or 15 compared to 10. When we simplify these, we will see that we get 3/2, 3/2, and 3/2. So that proves that these are proportional. So our scale factor is 3/2, or 1.5. Our triangle, our new one, is 1.5 size of the initial, talking about the sides or the perimeter, but not area. So perimeter of our new triangle is 36. The perimeter of the initial is 24. Let's compare new to initial, and that simplifies by a factor of 12, 3/2. Area of a rectangle is the length times the width divided by, or I should say, the height times the base. Let's change it to that. Height times the base divided by 2. So our new triangle has an area 9 times 12 divided by 2 is 54. Our initial 6 times 8 divided by 2 is 24. And let's compare And when we simplify this, we get 9/4. They have a factor of 6. And if we take the scale factor, 3/2, and we square it, we do confirm that we are correct. 3 times 3 is 9. 2 times 2 is 4. Okay, pause the video, complete all of these problems before moving on to the next part of this lesson. Proportions can be used to determine an unknown measure in a scale drawing. So proportions, and we learned this in our previous lesson, can be used to determine an unknown measure in a scale drawing. When setting up a proportion, again, this is a repeat from the previous lesson. When setting up a proportion, it is important to keep the same units in both numerators and then the same units in both denominators. Make sure like parts correspond or match up. Okay. The scale for a ballpark drawing is 2 inches equals 15 yards. So we have 2 inches in the drawing represents 15 yards for the actual baseball. The length of the ballpark drawing is 20 inches. Find the length of the actual park. So 2 inches is talking about the drawing, and they give us a dimension or a measurement for the drawing. So we're going to make sure we have inches to inches. So this is the drawing and the drawing. And then we want to know what is the actual length of the ballpark. So we're going to cross multiply. We're going to divide by 2. And x equals 150. So it's 150 yards. Don't forget your units. Okay, in this example, we have a drawing of a pool. It says 1.5 inches is equal to 4 feet. So 1.5 inches is equal to 4 feet. In the drawing, we have 18 inches. Let's find the actual length of the pool in feet. So we're going to cross and multiply. (18 times 4). We can use our calculator, divide by 1.5, or you can say 1.5. And x equals 48, and that is 48 feet for the actual pool. Okay, pause the video, complete the following problems, make sure